It maybe goes without saying that a company needs to speak the same languages as its customers. And that can mean managing things like online customer service, marketing, and sales in perhaps dozens of different languages. Not that long ago, companies would need to build entirely different chatbots for each one. And it's still the case that AI doesn't speak many of the world's languages at all. I'm Jennifer Strong, and this is Shift.
Now here on the steering column is a device called Auto Cruise. You simply set the speed you want.
Self-driving robo-taxis are already on the road in US cities.
As the disc rotates, a mirror reflects the light in the way that depends on how the signal was recorded.
This is the 100 terabyte. I present to you Electro, the Moto Man.
Ladies and gentlemen.
I would say that one of my greatest skills is my ability to interact with humans.
This episode, we meet founders working at the heart of some of these issues.
Hackers and cybercriminals have always held this kind of special fascination.
Obviously, I can't tell you too much about what I do.
It's a game. Who's the best hacker? And I was like, well, this is child's play.
I'm Dina Temple-Raston, and on the Click Here podcast, you'll meet them and the people trying to stop them.
We're not afraid of the attack. We're afraid of the creativity and the intelligence of the human being behind it.
Click Here, stories about the people making and breaking our digital world.
AI machines, satellite, engine ignition,
click here,
and liftoff.
Every Tuesday, wherever you get your podcasts.
Most people that are going to try to translate things are probably going to do AI first, right? Because it's easy, it's there, you can try it, you have immediate results. My name is Vasco Pedro. I'm co-founder and CEO of Unbabel.
We're taking a walk around its headquarters in Lisbon, Portugal.
There's this weird thing with language, which is, in essence, we're kind of all experts. We've been using it since forever, and so we think it's easy, but it really isn't. And when you start translating your website or doing something, you think, oh, I'm just going to plug this here, click next, and done. And then you realize, oh, wow, no, it's much more complicated, right? And so this whole thing quickly gets out of hand where you're doing a bunch of languages and a lot of different contents and a lot of different sources. And so to manage that in a scalable way requires thinking about it differently.
His platform uses a mix of AI and human translation to help companies expand to new markets.
How do we enable customer service agents when they're in a contact center and someone's reaching out through email or chat to respond in many languages? We integrated with Zendesk and Salesforce. Now we've expanded that to a bunch of use cases. So your website, your marketing content, your sales collateral, your product descriptions, medical, legal. And so it's been a progress of both expanding across languages. So we now do, I think, 130 languages, and we do a lot of different verticals. And what I mean by this is that we went from a world that was pretty much project driven, like, okay, I have my manual and here it is, you get it translated, you give it back to me, to stream-based, where content is constantly being created and you need to have translation capabilities embedded directly into the content creation pipelines. So AI is really what's enabling that, but you need to start thinking differently about how you set up your infrastructure, which we're more and more calling language operations because it's kind of an operational framework.
And he's working on other new ways of communicating too, including silently, without speaking or typing.
It's kind of like the beginning of the cognitive evolution of the human being amplified by AI. I think we're just in the beginning of that. But I like to think that the way that we have our limbic system and our neocortex, which evolved over millions of years, we're kind of seeing the beginning of a third layer of our brain that is going to exist outside of our brain. So access to outside computational capabilities, AI enhancements directly plugged into our brain. Some projects already on the way, things like Neuralink, et cetera, but we wanted to do something that was non-invasive. And so we started thinking is, well, what if we create a non-invasive neural interface and we kind of use that to enable a way to express biosignals that we can then decode into some form of communication.
He says large language models, or LLMs, have helped simplify things, So instead of relying on biosignals alone to communicate, LLMs trained on personal data can generate some likely replies to common questions, which users can pick from and send using biosignals.
And the result is it feels a bit magic because it's a bit like you're almost telepathy, right? You're just thinking and you're replying. And the long term is, we started doing some studies and it's like, okay, well, ALS patients have to rely on non-verbal communication. Stephen Hawking, for example, would communicate about 2 words per minute, which is very slow, and he was still able to do really amazing things. And so we were thinking, okay, when do we get to a point where this is consumer grade, right? And it's about 80 words or more is when you can start communicating effectively. And from the beginning, that's always been the goal. It's like, how do we get to a point where this is about enhancing regular human cognition?
The message itself looks like any other text on your phone. And since a person on the receiving end of one of these messages is probably not standing right next to the person they're chatting with, they're unlikely to know the difference. But I'm right here.
So it looks a bit like I'm just reading their thoughts, right? But actually that's not what's happening. What's happening is when the message arrives, the person hears the message in the headphone in the ear, like I have, and then the LLM is suggesting, here's a few possible answers based on your preferences and what I know about you that could make sense for you to answer. And I'm able to use an EMG sensor that I have in my arm to navigate that and to kind of select the answer that I want to send. Now, this is version 1. We're working on version 2, where you can start typing, so you can initiate things. It's not efficient enough at this point that we want to deploy it yet into patients, but we're getting close. Let's say 80-90% of the time, the LLM will pick the right answer that you want to give anyway, because especially with ALS patients, a lot of it is repetitive, kind of like, what do you want to eat? Do you want to do this? What about that? Are you comfortable here or not? But then we'll give them an option of, if they want to do something outside of that. It's also fairly efficient because you only need to type 1 or 2 words and the LLM will expand that into a fully fledged answer or interaction. And so for me, what it feels like is there is an AI that is assisting me, and then I'm able to select what is the thing that I want to say, right? So it's not reading my thoughts, it's just creating a new communication channel that I can choose to use to express myself.
If a user is open to it, they'll upload past conversations from texting apps to help the system have greater context for these replies, which is how, when I asked Vasco what kind of pizza he likes, he was able to respond right away that he usually orders something with greens instead.
So I have an EMG sensor here. It's plugged into like 3 different points. One is for bass and the other is for difference in... This is non-invasive, meaning there's no implants, right? So you have the sensors that you put on the skin that measure electrical activity around your muscles. They're fairly sensitive, so you don't even have to really contract your muscles. You can, but they should be able to pick it up just by getting the impulses there. If you have on both arms, it means that you have 3 or 4 signals that you can generate, right? And so you can start using them effectively to send instructions to the LLM. I'm using it in my arm. Obviously, ALS patients' arm muscles tend to be the ones affected earlier on. So we have a headband for ALS patients that kind of sensors on muscles that are closer to the brain, makes it easier. The next step from the hardware perspective is kind of explore things that are not even dependent on the muscles at all. So things like EEG. We have some interesting companies in Europe developing different technologies. One company is trying to develop for the AirPods itself, the little tip of the AirPod. That material is also an EEG sensor. Because it's in the ear, you would bypass kind of part of the skull. That's kind of the idea. It's not quite there yet. And it's been interesting because the whole industry of wellness is also developing a lot of sensors for meditation and for sleeping. And there's some overlap in that technology. So wearables in general are also seeing a lot of progress. And so we can benefit from that progress as well.
Next, Vasco and his colleague show me how it works.
I'm Paulo Dimas. I'm leading product innovation at Unbabel. And what I'm going to do now is I'm going to send a message to Vasco, and Vasco is going to reply silently, invisibly to this message, okay? So this is a normal text message, and I'm going to ask him how he's feeling. So I just sent the message, and at this time, he's listening to this question on his AirPods, okay? And let's see if he can answer without typing or speaking. Okay, moment of silence. Okay, here it is. Doing well, thanks. The presentation's been a great experience. Okay, what would you like to eat for lunch? Typing it, and I'm going to press send. And I just sent the second message to Vasco. And let's see if you can answer without speaking or typing. And we can discuss what we're going to have for lunch. Not too hungry. Might skip lunch today. This is very much Vasco, by the way. He skips lunch a lot of times. So why this answer? Why was he so fast replying to this message? Because the AI persona knows a lot about Vasco's interests, about his preferences. It also learns over time, and so it gets better continuously. Now the model is learning all the time. Learns about his relations. So if he's talking with me, it's different from talking with his daughters, colleagues, and so on.
My attention turns back to Vasco, who's sitting next to me with a funny look on his face. There's been a tweak to the system that surprised him. That voice in his headphones, it's no longer a generic robo-voice. It sounds just like him.
Yeah, it's like the voice synthesizes mine that I'm hearing. So it's like, there's a moment like I'm speaking to myself. It's it's quite cool, but it was like, wow. And it does sound like me. And I'm like, where did they get my voice?
After the break, we meet a woman building AI for African languages. We'll be back right after this.
Because you're listening to this podcast, I'm assuming you're interested in staying on top of the latest trends, news, and more. So I want to tell you about another show. It's called Web3 with A16Z Crypto, but it's really about the future of the internet, future of creators, future of business, future of the way we work and live. It's for anyone seeking to understand the latest tech trends direct from experts with high insights per minute, given your time and attention are so valuable. Follow Web3 with A16Z in your podcast app now.
So we create language models for indigenous languages. My name is Pelonomi Moiloa, and I am CEO and co-founder of Lelapa AI. They are what we describe as an under-resourced language. This is prominent in historically oral-based cultures, so a lot of Arabic cultures, a lot of African cultures. A lot of our knowledge creation is in storytelling. It's passed down from generation to generation. It's not written pen and paper with one version of the truth. But it means that a record of that history and of the language is not readily available, because if you don't know it, then you don't have access to it. I don't know what it is about this room, but it makes me feel like I need to get philosophical, because the first sentence that came to my mind when thinking about what Lelapa AI is, it's for us as a promise, you know? So our mission more generally is to enable a positive uptick in the quality of life of Africans, which is super broad. But I think if your vision is too small, then you run the risk of putting your bar too low. And the way that we're approaching this problem is through language. We believe that language is the first step in any direction.
The challenge of working with under-resourced languages is that there's much less data available for training models.
What is required to teach a machine a language is like lots and lots and lots of examples of that language. In the same way that you teach a child, this is an apple, you repeat apple, apple, apple. Actually, the first one's normally mama, 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 again and again and again, and eventually the baby says mama. AI is the same, except you have to tell it mama way more many times than you have to tell a baby. So if you don't have a significant body of text or vocal evidence to teach the machine just doesn't understand very well. But there are mechanisms of how to get around that. And that's what Lelapa specializes in. So making sure that the data quality that you feed to a machine is at such a level that it requires less examples to learn from. We also make sure that it's quite domain specific. So you may teach the AI medical stuff so that it knows about the medical field, but you don't then confuse it with another domain like finance, for example. And keeping those domains somewhat separate helps you to train a model that performs really, really well with far less data.
Recently, she released a tool that identifies 4 languages spoken in South Africa, and the team is working to add others. It can be used alone or integrated into ChatGPT and other tools.
And what that means predominantly at this stage for us is providing customer service functionalities for business that operate on the continent. So if you're a bank and you need to communicate with your customers via text, or if you are a farmer who has some kind of agricultural tool that helps them determine what the weather might be, or to mitigate the risk of pest or disease, if somebody needs to get an insurance quote. Much of the internet access on the African continent is via mobile, which means that many of our communications are dependent on text and voice, but it isn't really available in the indigenous languages, which then means that people don't have access to that technology and then don't even have access to complain about it because customer service cannot process it. So that is the main domain that we're operating in at the moment. There is things like named entity recognition, which helps to identify common names, places, organizations, and objects within a text. This is then useful to provide functionality to conversational bots, for example, or to make the documents searchable. If you fed isiZulu text to an English model and asked it certain questions about it, it wouldn't be able to answer it because it doesn't have those basic functions in that language. Yeah, and transcription is another one. So just being able to convert speech to text, that is a large consideration in our model base. And that allows then text to be searchable, to be summarizable, et cetera, et cetera.
And her path to this point is an interesting one, with a few different stops along the way.
So I started out as an engineering student. It was a very collaborative environment. You can't survive engineering alone. And so I think that is where my community of practice started to build from. I was doing biomedical engineering because I was really interested in the human body and medicine and brains in particular. But the biomedical engineering industry in Africa is quite far behind. And I could have stayed there, but it just felt like if I were to create any kind of impact, it was too long-term a goal that I was willing to put out for it. And I needed something a lot more urgent. And around this time, I then moved over into electrical engineering, pure electrical software stuff. And in that, I was exposed to data science for the first time in 2014. So I took some machine learning courses, and then I was hooked on collecting data, discovering insights, visualizing it to try and understand it and the world a little bit better. And that, I guess, naturally unfolded into the space of language with my amazing co-founding team who co-founded an initiative called Masakane, which is an incredible grassroots research movement dedicated to improving the quality of NLP research on the African continent for African languages. And they've done such an incredible job, but it's now time to turn that into something sustainable and something that genuinely brings about the change that it was created to. And yeah, moved from ordinary data science in the finance field, which was the first place I could find a job, to something a bit more meaningful and a bit more immediate in the impact it was able to generate. And my father's a huge advocate for language, is very passionate about it. So in a way, it's in my blood, and here we are.
She also wants to create jobs that can keep skilled Africans from leaving to find work abroad and give them the opportunity to contribute to their communities and the social fabric of where they come from.
In many parts of the world, a country consists of many languages. Colonialism kind of cemented a language of instruction in those areas. The native languages of those native people still exist, and they are in the majority. So on the African continent, yes, many people are able to engage in French or in English or Portuguese, a few in Spanish, but the majority of people speak the languages that they grew up speaking in the village. And it means that those people who are unable to engage with French or English or something else that is well-versed in terms of what technology is able to offer are then unable to participate in information sharing opportunities, whether that be research papers or educational tools or news. But it also means that they're unable to necessarily communicate with technology. So, for example, in a Word document, all our names have a squiggly red line underneath because they're misspelled because they're unrecognized. If we were to speak our language into a WhatsApp recording to get it transcribed, the transcription would be nonsense. It would try to convert it to English. If we try to tell Google Maps to go to a particular place in the way that you pronounce the name, it wouldn't know what you were talking about. So in some ways, making technology speak our language seems sentimental, like, oh, they wanted to speak their language so that, I don't know, they can have conversations with it. In practicality, it means that people are denied access to products and services that could help make their lives so much better. A reminder that technology is here to expand our capacity to be able to problem solve, to deal with things. And that means languages don't have to die. Culture doesn't have to die. Globalization doesn't have to mean homogeneity. Technology is here to help connect us across those cultural barriers, but it doesn't mean we have to let go of who we are.
This show is produced by me and Anthony Green with help from Emma Cillekens. It's mixed by Garret Lang with original music from him and Jacob Gorski. Thanks for listening. I'm Jennifer Strong.